So I'm going to be the last talk between you and lunch. Anyway, a little bit of myself. My name's Davis. I work as an engineer in the Personalization Infrastructure team. And I'm going to talk about kind of a marquee project we've been working on inside the personalization team to deal with kind of the collection of challenges that we've had to deal with when trying to personalize the Netflix experience. So to kind of motivate this a little bit, we'll talk about, okay, what does it mean, or what is the goal of personalization at Netflix? Oh, of course now. There we go. So our goal is to help members find content to watch and enjoy so we can create this virtual cycle of satisfaction and retention amongst our members. It's sort of the core tenet of what we want to be able to do. So now what does it mean to actually personalize the Netflix experience? I'm sure some of you are maybe familiar with this page. And in essence, everything that you see on this page is a function of personalization algorithms. Not only the rows that appear, but the order in which they appear, as well as the order of titles within each row. So the goal here is to make sure that you are as close as possible to what we think you might enjoy watching at any given time on the experience. And all of these rankings and recommendations are driven by machine learning pipelines. So what does kind of a machine learning pipeline look like at Netflix? And this will probably look familiar to anybody who's done this. We start with user selection, sort of getting our sample data, what we want to use to inform our model. And then we have to label that data. We have to run it through feature generation, feature encoders, some notion about how we label that data. And then that's fed into, obviously, training our model, or maybe potentially a collection of models. And then we go through a process of validation, deciding, okay, does this meet criteria for prediction accuracy? Have we found a stable sort of minima for our convex optimization? And once all these things are sort of satisfied, then we can sort of publish the model for use in online systems. Now, this seems kind of neat and tidy and straightforward, but obviously in reality, things are never quite that straightforward. And it's a little bit more heterogeneous. For example, when you actually get your data, that may start as a Hive query, deciding, okay, I need access to active members and needs to access with our current sort of data warehousing solution. And then we may have a collection of Python software to decide, okay, how are we going to separate this data into training, test, validation. And then that'll be fed into potentially a myriad of model training pipelines, whether it's regional or global model. And each of those may potentially leverage different technologies because they have different requirements. A global model is going to need to leverage a larger quantity of data. So we need to leverage Spark and use maybe a more approximate sort of machine learning approach. Whereas the regional model, we can use something like R to sort of do a more direct optimization. And these pipelines need to be able to run concurrently because obviously we need to be able to meet our time budget for retraining these models. And then once all that's done, then we need to go through a process potentially of model selection. And that'll use potentially yet another sort of technology stack, whether that's just a Scala application, standalone application. And then, potentially, again, a separate stack for publishing that into our online systems. So this sort of motivates the sort of the issue that we've kind of run into, which is that there's a lot of different technology that we need to interface in a cohesive way to ensure that we get sort of reliable, easy to use access and the ability to experiment within personalization. So fundamentally, in the machine learning space, it should come to no surprise there's a ton of innovation. And that breeds heterogeneous environments to run on. Whether that's Spark or R or Docker applications or GraphX API. So we needed a platform and sort of a framework that could both orchestrate and execute across these heterogeneous environments. That said, Spark is used very heavily inside of the personalization team. So that was one where it was sort of we had to have a batteries included solution for running Spark in these workflows. So that was definitely a hard requirement for us. Now these first 2 points kind of mandated that we be able to sort of separate orchestration from execution. We should be able to sort of change out how we sort of farm out the work from the actual implementation of orchestrating these workflows. Now we also have to support a bunch of different teams, whether it's search or video ranking or the similar video team. So we need to be able to support multi-tenancy, right, and be sort of conscious both of our time budget as well as cost budget for running and training these workflows. And there's also sort of machine learning constructs, in particular something like a parameter sweep that may mandate that we have like a 30,000 sort of branch fan out for a sort of concurrent training, right? So there's sort of a scale aspect here that we need to be very conscious of. And with these challenges in mind, we came up with our Mazeon workflow system. Now, this is a general purpose workflow orchestration engine and scheduling framework. It currently designates execution to resource managers like Meson or Yarn, but fundamentally it's optimized for machine learning pipelines and visualization. And we actually put out a blog a little while ago. If you want to follow this link or find it on our tech blog, if you want to read a little bit more in depth about sort of all the features that it has, and I'm just going to kind of touch on sort of the high points in this talk. And I should point out our plan is to open source this in the future. So our hope is that once we have what we feel is a concrete solution to the set of problems we've solved, we feel that they are applicable to the industry at large. So the architecture as it sits, so Mazeon is a Scala application. It sits as a Mesos framework. It manages sort of state persistence. It implements, obviously, the Mesos framework itself. We have a collection of plugins and extensions to enable this system to interface with the various subsystems inside of Netflix, whether it's the the data announcement system, or the various places where we might be able to ingest data. And we needed to be able to support the ability for users to come in and say, oh, I need to use tool X. I can do that very simply with a simple extension, and thereby tailor Mazeon for their particular use case. And then execution itself, once we've sort of captured that state and how the flow of the workflow is going to behave, the actual execution is delegated to a Mesos cluster, running sort of a custom a Mazeon executor to enable us to sort of communicate nuanced information about the runtime of these workflows back to the actual Mazeon service for surfacing in a UI for the user. Now, talking a little bit more about this plugin and extension system, we wanted to be able to support a lot of different sort of sub-step types. So the hope is that when the algo engineers come to use Mazeon, it's sort of batteries included, right? We already have sort of de facto solutions for the various sub-pieces they may need to sort of glue together. And a lot of this was sort of aided in particular by the fact that we could use sort of Scala's rich sort of trait system and multi-inheritance. So we have this notion of sort of a thin cake pattern where we glue together various sub-implementations, and it's very easy to sort of create these new pieces of execution for the particular use case. Moreover, all of these pieces need to be parameterized, obviously. So we needed to sort of support a rich parameter system. In the simplest case, a Hive query needs to be motivated by a timestamp, like when are you going to actually fetch your data. And then this is going to emit sort of the location of that user data set, which will be consumed by steps downstream. And this sort of process can, ad nauseum, can sort of, as snippets of useful information need to be able to flow through a workflow. So once you have these steps parameterized, then you get to the part where your workflow actually has to run. And so when a step is actually executing, we need to ensure that we surface as much sort of useful information to the user as possible. And that comes in the form of runtime logs, as well as access to sort of nuanced progress information, as well as artifacts about maybe, okay, what's sort of your feature importance information for that particular step run, or how many records did you process, where's the location of the user data set that this thing has emitted. And all of this sort of necessitated us to use this sort of custom executor that I mentioned earlier. Now, one piece of this artifact system that is particularly useful and important has to do with visualization. So a big motivator for this was the notion that very often in ML pipelines, there's lots of intermediate data that you want to inspect, and not only for the instance of a single run, but over the course of multiple runs. So we want to be able to chain together all this information from a single step so that you can sort of track its behavior over time, whether that's something like feature importance or convergence time, and understand how it behaves over time in the system so you can identify useful signals. Something like feature importance is a great way to sort of potentially inform future hypotheses that may go into other A/B tests later. Now, As I alluded to earlier, workflows are rarely as simple as do A, then B, then C. So we needed to sort of include a number of structured constructs for how to sort of stick these Legos together. So in the simplest sense, obviously we can support something as simple as do A, then B, then C. But we also need to support this notion of sort of a fork join notion within a workflow, whereby you need to run several subflows, wait on their completion before proceeding. Something like XOR, where you have sort of conditional flow through your workflow that may be mandated by the output of an ingress step. We also need to support this notion of for each, which is sort of where that came from, that requirement of needing to do like parameter search, right? So the actual fan out of your workflow will be sort of controlled by particular tuning parameters you've decided. So how big is this grid sweep that I want to run for this particular workflow? And we also need to be able to support loops. In particular, if we get to a validation step, that may indicate that we need to actually go back and rerun a subsection of the workflow again, or expand our user set if we think data quality is low or something like that. And now we have two ways for users to sort of construct these workflows. First is through the web UI. We have essentially just a graphical way to represent these and manipulate them and create them. And that's useful for sort of debugging these workflows, prototyping things, and sort of getting used to sort of how the system behaves. But the more common way that people actually, our users actually create and manage these workflows is through a DSL. And this is where the power of Scala was sort of made clear to be sort of a correct choice for us, was the ability to sort of define a rich, type-checked, fluent system for defining these workflows and managing their life cycle over the course of development. And this is how the vast majority of users describe and manage their workflow definitions. So we'll talk a little bit, what was the Scala stack that we ended up using to build this application? So the web server is built on top of Akka HTTP, making heavy use of the routing DSL and Spray JSON. We started to dip our toes into using the actor system on the construction of our actual Mesos framework. So this is sort of one of our larger projects in Scala within the team, and so we are sort of taking a measured approach to trying out these new libraries. We were sort of wary of big heavyweight frameworks, and we wanted to sort of be able to test out actors in a small way. We also use Scaldi for dependency injection, and our future work is to actually extend our initial experience with actors was quite good, and we're looking at actually using the FSM trait to sort of restructure most of, if not all, of our current state machine, with the hope that we can leverage sort of a higher level of concurrency for workflow processing. Because as the state machine grew, it was sort of organic as requirements came up, and we feel that with FSM we can take a much more measured approach to redescribing the state machine in a very sort of clean, reusable, and manageable way. So some numbers. Everybody likes numbers. Our current primary Mazeon cluster manages hundreds of concurrent jobs. At any given point, it'll run between 100 and 200 workflows with thousands of steps. And the execution of these workflows is farmed out to a cluster of about 750 nodes with 6,000 cores and about 40 terabytes of memory. And this cluster essentially obviously manages the runtime of the steps themselves, the Spark frameworks that are sort of started as a function of those steps firing off, and a few odd Docker applications as well. And we have a few smaller clusters for users to sort of test out in isolation if they like as well. So that's it for Mazeon. This is my contact info. If any of that sounds interesting to you, I'll let you know as we're hiring as well in the personalization team. So if any of those problems sort of excite you or you'd be interested in, please come and talk to us. Are there any questions?
So you use the DSL to define your DAG.
Correct. Although to be clear, it's not a DAG. It's because we do allow cycles. But yes, so the question is we use DSL to define our graph.
Yes, but after you make changes to that by changing DSL to that file, do you need to recompile and release to certain place to make it usable?
Yes. Yeah. So the Mazeon workflow system itself actually has, to repeat the question, if you modify a DSL definition, how does the life cycle of that update actually manifest itself into the runtime system? So the runtime system actually has a rudimentary sort of versioning system, so you can sort of track state and you sort of manage a prototype and then you can sort of make that active. So you can independently version your DSL in sort of a traditional build system, under version control. And then when you have a stable build, you can essentially say, okay, this is my new workflow definition. I'm going to publish that to the runtime Mazeon system, so that'll actually publish a new version based on your new DSL definition. That'll get uploaded to the server along with any sort of changes to your runtime artifacts that you may need. And then that'll be made active for future runs of the workflow.
So that means I will create a pull request to change the DAG definition with DSL and merge it and release it.
So the first part is entirely up to the users, right? They could define a DSL, but the actual uploading it to the Mazeon server is merely an API call. So it'll pull down, compile their DSL, translate it into the appropriate API call, and then push that to the server. Yes?
So the individual steps of the job that you have, those are like separate Spark jobs, for example? Would those be separate Spark jobs or?
So the question is, are the various steps separate Spark jobs? And the answer is yes.
Basically, so you probably would not be able to share the Spark context and all the sharings by HDFS or whatever store that you have doing.
So we actually use, so the question is are you able to share a Spark context between two steps? Currently, no. And there's good reason for that. Oftentimes we want to be able to sort of isolate resource requirements for various steps, because Spark itself is not great at sort of adjusting its resource consumption over the course of a job. Dynamic allocation is getting there. We're getting close to that solution. But it's generally easier to make small, focused Spark jobs that use exactly the resource footprint they need and emit data for downstream steps. Yes?
Does your DSL also allow you to affect things with pre-processing? So you can do parameter search on your parameters of your data mining models. Does it also let you go back and say, do more sophisticated pre-processing? Parameters driving that?
So the question is I'm not sure I totally understand the question. Does it have to do, does the DSL enable us to do?
The DSL can control parameter search for parameters in models.
Yes.
For model build.
Yeah, you could define your definition or workflow may hard code what your sort of parameter space is, and then it'll do a Cartesian search across all those combinations or something like that.
So sometimes in a data mining project, sprint 1, I'll do basic pre-processing, model building. Sprint 2, I'll get into more sophisticated pre-processing. So then could I have DSL parameters specifying the more sophisticated pre-processing?
Absolutely, yeah.
Okay.
It's very pluggable, and moreover, it's very generic, right? The idea is a step is merely just a unit of execution. We have some batteries included ways for how to define these steps, but at the end of the day, your DSL is as a Scala code, right? So you could define any sort of complex flow or how you're going to manage the lifecycle of those DSLs is very fluid. So yes, yeah.
So how do you manage multi-user workflows?
So the question is, how do we manage multi-user workflows? Now, do you mean multiple users that are concerned about the same workflow, or so typically, we don't build tooling around trying to sort of do like strict version control for multiple users for the same workflow definition. We give sort of atomic updates for updating a workflow definition, but the onus is more on the users to be able to say, okay, we're collaborating on the definition of this workflow, and the tooling inside of Netflix is very heavily using sort of automated build systems and version control. So those tools sort of solve that problem for us. Yes, in the back?
Where do you guys maintain state?
So the question is, where do we maintain state? Our current solution for state maintenance is Cassandra. The tooling for Cassandra at Netflix is very, very good. That was a very, very easy solution for us to use right away.
Is that a pluggable thing?
So the question is the data store a pluggable thing? Yes, absolutely. The actual API for doing state maintenance is a simple key value store. So anything that can implement key value, you can store your state in. Yes?
Yeah, so what other options did you consider for DSL? So I'm coming from made some DSLs with
Yeah, so to be totally honest, I mean, we didn't have total clairvoyance before going into this with Scala. I think a big motivator for us to choose Scala was the Spark interoperability, and we already had a lot of people who were on board with the language, right, and saw its merits, just in general software development. And when we got to the point of the need for this DSL to describe it, it was immediate, like, oh, like this is an obvious win. Yeah, so that was. I can't say that we had like an immediate like, yes, we're using this for the DSL, but it was a lovely discovery.
Was Groovy evaluated?
No, I don't recall that Groovy was evaluated. Yes.
So I'm guessing this is kind of supposed to be like a Scala version of Airflow. Did you guys consider Airflow, or like how would you say this is different?
That's a great question. So the question is how does this stack up against Airflow? So had we considered Airflow? The answer is yes. Airflow is very much trying to solve a similar set of problems. And our primary issue with Airflow was that because of its very Python-centric approach, it's very difficult for us to actually integrate Spark jobs into Airflow. And because Spark was used so heavily inside the personalization team, it was almost a non-starter for us. So we felt that we could take a better approach that targeted our set of technologies and then sort of branch from there to sort of cover everything.
So quick follow-up to that.
Mhm.
It is possible. I mean, I've gotten Airflow working with Scala.
Yeah.
What did you see as your primary pain points in trying to like get that ubiquitous across your teams?
Common pain point, so you're saying like amongst our workflows?
Right. Like so what made you feel like I'm going to try to tackle this problem by creating an alternative to Airflow rather than just making your Scala jobs?
So one of the things is actually when we started out with Mazeon, Airflow wasn't that mature, about a year and a half ago. That's one of the things. And the other thing is because of the way we did build the system, Spark is considered a personal citizen natively, and so it's not just the orchestration, but also the compute that's bundled together. You can see a lot of steps that you should things you can do with Spark. So that's one thing that stands out. The other thing is also we have loops, and so if you have a standard CAD processor, you won't have loops in there. And there were some use cases where we found that we needed to support loops, like when you had to something failed, you have to validate, go back, and rerun the pipeline. And so there's that. There's like a million workflow systems out there, and so we basically tried to tailor our needs, and it got enough adoption that we felt that we could actually do that.
Yes. So the question is when we expect to open source that. Our hope is for 2017. We can't be terribly more specific than that. I mean, we have a lot of obviously internal pressure to cover some features and things like this, and open sourcing a project in and of itself is a bit of a task. But if anyone's interested in helping us do that, please again come talk to us. But yeah, we're shooting for 2017. Yes.
How do you think about the interactions between the people like actually building the models and the people sort of building the infrastructure the models run on? Are they the same people, or?
That's a great question. So he's asking about, so the question is, what is the interaction between the people actually building the models and the people building the infrastructure? And I mean, that's a hard problem. And so we sort of have a separation between infrastructure and model building right now. But with the collaboration, we want to sort of make sure we have sufficient overlap so that people who are building the model are sort of aware of the infrastructure requirements. But yeah, it's a common problem we run into. Those building models are potentially don't want to be concerned too much about, okay, what does it mean to be sort of resource efficient inside of a Spark job? And so we try to build as many tools as possible to try to abstract away a lot of sort of the compute layer infrastructure and try to build those abstractions up. It's not perfect right now, but Mazeon is sort of our first step to try and sort of bump that abstraction layer up, because before that we essentially was sort of much harder than it is now.
I'll add one more thing to it. So the model for extensibility in Meson is such that you can write custom steps. And so one of the things that once people start playing with Mazeon and they figure out that there's this piece of code that is repeatable and it's used across multiple pipelines, then they can essentially make that into a custom step, and that can be reused by anybody else. And so that's that model that sort of improves the reusability and collaboration. But in general, sort of we build a platform there, and the data scientists and the algo researchers sort of tend to write the core code for the technology.
Was that library part of the original implementation, or do you guys just see people copying and pasting and build it?
So we had that in mind as a vision on where we wanted to do, and so we actually structured the code also in such a way that there's a Netflix specific version and there's something that could eventually be open source, and so that extensibility was there, but we didn't pay much attention to it until we started running into the copy and paste problems, and we saying that we really could do a better job there.
Cool.
Yes?
Can you speak to the R integration? Is it just read data off disk, or is it our Java, Scala calling Java calling R, passing data streaming? Or?
Yeah, it's not. Say again? Yeah, it's the latter. So it's just Java calling R. It's not a terribly sophisticated integration. It's not a super common use case, but it was enough that we felt we needed to at least include that. And there's not a lot of coordination involved in that piece, so it doesn't need to be terribly sophisticated. Yes?
What is your use case to have loops in your workflows?
The common use case is the question was what was the use case for loops? And the use case is, these workflows will go all the way from ingesting data to publishing a model for availability in an online system. And the loop is a way for us to encode instruction about if you get to the validation step, which is sort of the last piece before you decide to publish, is it okay to publish or not? And we didn't want to just terminate the workflow and start all the way from the beginning. We wanted to be able to start from a memoized piece and rerun from there to say, expand. So I say I got to validation and data quality was too low. So we got to run back and rerun that step with an adjusted parameter to sort of get where we need to be. Yes?
Does the user still have any control over how that dashboard is laid out? And if so, how has that impacted overall user experience?
So the question is do users have control over that dashboard layout? And the answer is not really. For the visualization piece, they do. But for the most part, what's presented in front of the workflow is mostly a function of, I guess there's some subtle control when you write a custom step. You can define certain interesting pieces of artifacts. They'll be emitted, and those will be presented in the dashboard along with other relevant data. But for the most part, it's fairly rigid. So we haven't seen a whole lot of user friction or control there.
By users, I mean me as a consumer, I subscribe to Netflix, you present this dashboard.
Oh, I see what you're saying.
Not the folks consuming.
Got it. Okay, got it.
Excuse me for not being more clear.
Sorry, so then can you repeat the question again in that new context?
So for the end users
Yes.
of that dashboard,
Yeah.
do they have any control over rows or columns?
No.
How does that impact the overall satisfaction with the user experience?
So okay, now we're getting to sort of market questions about Netflix. So yeah, I won't go too far down this road. The answer is no. There's a lot of pressure for sort of adding advanced features to Netflix, but generally we've wanted to make the interface as sort of seamless and simple and approachable as possible. And so we sort of erred on the side of a simpler side of the interface. I mean, we do hear requests for more advanced sort of user interface, but we've yet to have a strong answer for why that would necessarily improve retention and engagement across sort of a wider user base.
We get that question all the time, all
Yeah.
over the place, right? Netflix is nothing if not data driven. So we see, we obviously take an input what our customers are asking for, but at the end of the day, every single, literally, areas of pixel in that interface that you see have product managers behind them who are trying to do all sorts of A/B tests around it. So once we get data, our key metrics being, more streaming, people are watching more retention, people are staying more. And so we basically use that data to figure out where the interest is. I mean, at the end of the day, providing too much choice to customer has its downsides too. So that's something that we feel that we're getting good coverage, we're getting good streaming, and we try to optimize those experiences.
Yes?
How you organize your logs? So your log could be from different sources, right? Some from Spark, some from Hive, some from JavaScript. But they're from different sources. And are you having the job to collecting all the logs into some on computer like Cloud or?
Yeah, so that's a great question. So the question is, how do we deal with logs, right? Because the stuff's running all over the place. There's lots of interesting information. So Mesos itself gets us a little bit of the way there. So we utilize the Mesos API to surface the logs from the actual execution of the step on the Mesos cluster to the UI. But moreover, with things like Spark, right, you might have, 10 or 100 instances of those separate log places. And to solve that problem, we use Elasticsearch and Logstash. Sort of pull them into a centralized place so they're searchable and indexed by your workflow. So say, I want all logs from the output of this workflow step, bam, and you can sort of search through them and explore them and understand what's going on.
But that's outside of the interface of Meson itself, right?
Yeah.
It links to it, you can go to your own Logstash, Elasticsearch, and have your own deployment. Key part is it's indexed by the workflow ID.
Yep.
So then you can label.
Any more questions? All right.